talk about our cosine functions. So if you refer back to where I had sketched the basic cosine graph, you always are starting at 1, then you're going down to 0, -1, 0, and then back up to 1 over a period of 2 pi. So we kind of just sketched these based off of, you know, where we normally are. I'm going to actually give you like a set way of doing these. So the first thing that you're going to do is you're going to think about where your points normally are. Okay? So we have 5 key points. All right? And the first one is when x is 0, and then pi over 2, and then pi, 3 pi over 2, and then 2 pi. And what I like to do is I like to write what I normally am sitting on for a y value. That way I kind of have an outline here. So just right above where I'm going to put my value, I normally start at 1, and then my y value is 0, and then down to -1, back up to 0, and then up to 1. But when I multiply by a half, what that's going to do is it's going to take whatever I normally have as a y value, and it's going to cut it in half. So I'm literally just going to multiply this number right here by 1/2. So if I take 1/2 times 1, that gives me 1/2. 1/2 times 0 is 0. 1/2 times -1 is -1/2. 1/2 times 0 is 0, and 1/2 times 1 is 1/2. So these are my key points. So when I draw my graph, I've got pi over 2, pi, 3 pi over 2, and 2 pi. And you really want to make sure that you space out fairly evenly. Of course, it's not going to be perfect because you're doing it by hand. And then I know that the highest up I'm going to go is 1/2. So I'm going to mark a spot for 1 and -1. And then I'm literally just going to plot these points. So 0, 1/2, pi over 2, 0, pi, -1/2, 3 pi over 2, 0, and 2 pi, 1/2. Then I'm just going to draw them in. And what I like for you to do, don't start like this is a V. These are curved. So I kind of start over just a little bit, and then you're going to kind of come and then make your minimum there, and then extend just a little bit past to show that that's going to keep going that direction. Now, as we start adding things and changing things in our basic trig functions, then things start changing. Like your period will change. You can move it up, you can move it down, you can stretch it, you can shrink it. You can do all kinds of things left and right. So we'll go through every step when we graph from here on out, just so we have like a consistent order of what we're going to do. So your period of sine and cosine, we're going to let b be some positive number, okay? The period of y equals a sine of bx, so b is just some number that you're multiplying times that value in there, and y equals a cosine bx is given by, I'm just going to take 2 pi. 2 pi is normally what my basic sine period is. It starts at 2 pi. Then it changes based on what you're multiplying times the x value. Or sometimes this is theta. Okay? They might put theta there, or they might put a different letter. So whenever I'm taking the sine of something, like let's say I was taking sine of 2x, that's the number that's being multiplied by x, right? So that represents the b. So I'm going to take that whole period, I'm going to divide it by whatever I'm multiplying times the x. Now, this one is written kind of funny, so we're going to rewrite it. Instead of saying I'm taking that x and dividing by 2, I can also say that I'm just multiplying it by 1/2, right? So when I think about the period, I'm going to take my 2 pi and I'm going to divide it by whatever I'm multiplying by the x right here. So I'm going to divide it by 1/2. And when I do that, I get 4 pi. So I know from start to finish, so one sine curve is like this, right? It goes up and it cuts. So from here to here is a distance of 4 pi. So in other words, it made it longer because normally it's just a distance of 2 pi, right? Now it's twice as long. It just stretched it out. Are you guys with me on this? So I have to figure out how much each section is. So there are 4 sections. I'm going to take the 4 pi and I'm going to divide it by 4. So every section is pi apart. Now notice, did I add or subtract any numbers anywhere? Did I multiply the front? No. All right, so for my key points, I'm going to say key KP. You have 5 of them. I didn't shift left or right, so I'm going to stay at 0. That's my starting point. And my ending point should be 4 pi, because if I start at 0 and it's 4 pi long, I should end at 4 pi. So what you're going to do is, where we took this 4 pi and we divided it into 4 equal pieces, this is what I'm going to add every time. So you might want to make yourself a note. So if I take this 0 and I add pi to it, that would be pi. And then if I add another pi, that would be 2 pi. And if I add another pi, that should be 3 pi. And when I add the last pi, that gets me to 4 pi, which is where I should end, right? So with sine, I normally start at 0. I go up to 1, drop back to 0, down to -1, and then I end at 0. And this is what I'm referring to. I'm referring to that very first 0, 1, 0, -1, 0, right? That's my basic one before I change anything. So that only changes if I add or subtract something to the outside of this function, or if I multiply something in the front of your sine. Did I multiply anything in the front here? No, so these will stay 0, 1, 0, -1, and 0. I just like to write them up there in the event that I do change. That way I know. All right, so I'm going to go ahead and draw myself a graph. And I'm counting by pi's. So I've got 1 pi, 2 pi, 3 pi, and 4 pi. And then the highest up I'm going to go is 1. And the lowest I'm going to go is -1. Then I just plot these points. So 0, 0, over to pi and up 1, over to 2 pi, 0, 3 pi, -1, and 4 pi, 0. So I start, and then you're going to make sure that you're not pointy and that you're curving. And I like to go a little bit past and draw the arrows in. So if you look at this, when we multiplied a number in the front, for instance, on this last one, when you multiply that number in the front, that changes how tall it is, right? So I'm only half up from that middle, okay, or half down. If it was a 2, then I would be up at 2, right? It makes it taller or shorter. When I change and multiply by a number inside, by that x, then it's going to stretch it left and right. So multiplying outside makes it go stretch farther up and down, right? Stretch or shrink. When I multiply inside here, that's going to stretch it out left and right. Okay? All right. So if I look at this one, I'm going to start off by, let's do our amplitude on this one. So remember your amplitude, that's the absolute value of whatever number is in front here, which in this case is a 1. So my amplitude is 1. Remember, that's how far it is from your center line up and your center line down. All right? Then let's talk about your period. So remember, the period, that's how long it is, all right, from beginning to end. So if I've got a 4 right here, I'm going to take my 2 pi and I'm going to divide that by 4, which gives me pi over 2. So from beginning to end, its length is pi over 2. All right? So I'm going to take that pi over 2 and I'm going to divide it by 4 to get how far each section is apart. So if I divide by 4, that gives me pi over 8. So this is what I'm going to add every time. Notice I didn't add or subtract any numbers, so I won't be shifting left, right, and up and down. So for my key points, I have 5 of them. I like to just write down all 5 at the same time. Since I didn't shift left or right, that means I'm going to start at 0. And since I know that it's pi over 2 in length, if I start at 0, then the ending one should be pi over 2. So every time I'm going to add pi over 8. So if I take 0 and I add pi over 8, that gets me pi over 8. And then if I add another pi over 8, that's 2 pi over 8, which is pi over 4. And if I add another pi over 8, that's 3 pi over 8. And if you add another pi over 8, that would be 4 pi over 8, which is pi over 2. And if you have your calculator, you can literally just say 0 plus pi over 8, plus pi over 8, plus pi over 8, plus pi over 8. And you at least know where you should end, right? And that is a big thing to help out if you know where you should end. All right, so with sine, I normally start at 0, go up to 1, drop to 0, drop to -1, and then end at 0. The only thing that's going to change that is when I add or subtract something inside, or add or subtract something outside of this part, or I multiply by a number up here. I'm not multiplying by any number, so this isn't going to stretch or shrink, so those numbers will stay the same. So now that I have my key points, I'm going to go ahead and draw my graph. Now, something to help you count so that you're equally spaced. If you count by pi over 8, because that's what you're adding every time, right? Then you should be able to equally space. So if I start at 0 and then I have pi over 8, and then I added another pi over 8, so that gave me pi over 4. And then I added another pi over 8, which gave me 3 pi over 8. And then I added another pi over 8, which gave me pi over 2. The highest up I'm going to go is 1, and the lowest is -1. And then I just plot the points. So 0, 0, pi over 8, 1, pi over 4, 0, 3 pi over 8, negative 1, and pi over 2, 0, and then you just connect your things and make sure that you're curving and not making them pointy. All right, so let's talk about translations, meaning we're going to move left and right, up and down. I don't know if we do any up and downs actually, but we're going to focus on the left and right for now. All right, so your constant c in this equation, so if I take the sine of a bunch of this stuff, right, this is going to create a translation that's left or right, okay? And so you've got that number that you're multiplying by the x, but now we're going to either add a number or we're going to subtract a number, okay? So here's the deal. This inside point will tell you where you should start and where you should end. All right, so you've got your amplitude. We've talked about the period. So your end points will be whatever you're taking the sine of equal to 0, and whatever you're taking the sine of equal to 2 pi. That will tell you the beginning and the end. All right, so let's start with amplitude. Remember, that's how far it is from the middle to the top and the middle to the bottom. So the amplitude would be the absolute value of 1/2. That's the number that's out front, which is 1/2. So I know that from the middle up and from the middle down, it's 1/2. Okay? Then let's talk about your period. The period is how far it is from beginning to the end, right? So I'm going to take 2 pi, and I will divide it by whatever I'm multiplying by x. So if you look right here in front of your x, you have a 1. So is that going to change this? No. So my period is still 2 pi, and I always like to go out to the side and divide that by 4 so I know what I should be adding every time. So if I take 2 pi divided by 4, that's pi over 2. That's what I should add every time, right? And you don't have to make this note every time. I'm just doing it for the purpose of reminding myself that's what I'm adding every time. Then we have to figure out our end points, because what happened here is I subtracted pi over 3. So that's actually going to shift me left and right. So for my end points, I'm going to take what I'm taking the sine of, which in this case is x minus pi over 3. And I'm going to set it equal to 0 because that's normally where I start, right? And then I'm also going to take it equal to 2 pi because that's normally where I end. So I have x minus pi over 3 is equal to 2 pi. So I'm going to add pi over 3. So x is equal to pi over 3. So this is where I will start on the left. I'm going to do the same thing over here. Add the pi over 3. So that gets me 7 pi over 3. And again, if you're not good at adding these, just plug that in your calculator. It will just tell you that it's 7 pi over 3. So what happened here is I normally start at 0, but now I'm starting at 1/3. That means that if I subtract a number, it's actually going to shift me to the right. And if I added the number, it would shift me to the left. All right, so when I start my points, instead of starting at 0, the very first one will be pi over 3. And the very last one should be 7 pi over 3. So this tells me where I'm going to start. This tells me where I should end. So to get the middle x values, you're going to be adding pi over 2 every time. So if I take pi over 3 and I add pi over 2, 5 pi over 6, And then I'm going to take that. It's already in my calculator, so I'm just going to press plus, and then pi over 2, which gets me 4 pi over 3. And then I add, again, pi over 2, which gets me 11 pi over 6. And then I always add it one more time, even though I know where I should be ending. If I add another pi over 2, it tells me it's 7 pi over 3. So I know that I have ended in the right spot. Okay? So with your sine, we're in sine, so we are normally at 0, and then we go up to 1, back to 0, down to -1, back to 0. But if you notice, I multiplied that equation by 1/2. So you need to take and multiply all of these numbers by 1/2. So 0 times 1/2 is 0. 1 times 1/2 is 1/2. 0 times 1/2 is 0. -1 times 1/2 is -1/2. And 0 times 1/2 is 0. So now we have our 5 points. All right, so what I like to do, I like to figure out what I should count by, because if I count by pi over 2's, then this isn't like a multiple of pi over 2, right? So I kind of like to decide, like for instance, a common denominator between all of these would be 6, right? So I'm going to count by pi over 6's. That way I can actually space them out evenly. So like all of these have 6 in common. So if I wanted this to have a bottom of 6, that would be the same thing as multiplying by 2. So I would get 2 pi over 6. Or this one, I'd multiply by 2 and get 8 pi over 6. And then 14 pi over 6. That way when I count, I need to go all the way from, I'm going to start at 1 pi over 6, right? And then it's 2 pi over 6 all the way up to 14. So I should have 14 tick marks on here, and this just helps me space out evenly. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is just a preference for me, okay? So this is 1 pi over 6, which means this is 2 pi over 6, which is my pi over 3, right? And then you have 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, which is my 4 pi over 3, 9, 10, 11 pi over 6, 12, 13, 14 pi over 6, which is my 7 pi over 3. So these are just to help me space out. All right. Now I'm equally spaced, so when I graph these, I'm going to go put one way up here. That way I'm not all squished. So that'd be 1/2. And then we'll do the same thing, -1/2. So we have pi over 3, 0. 5 pi over 6, 1/2. 4 pi over 3, -1/2. 11 pi over 6, 0. And then oh, I skipped. Might help if I put my dots in the right spot. I skipped my 0, didn't I? 4 pi over 3, 0. There we go. 11 pi over 6, -1/2. And then 7 pi over 3, 0. Then you just draw that in. So see how I normally start at 0, but I have shifted over pi over 3, right? Because I subtracted that pi over 3 inside those parentheses there. All right, so let's start with the amplitude. Also, you want to make sure you notice what you're in. We are We're graphing cosine, so we're going to be a little bit different. So I'm going to take the absolute value of the negative 3. So the absolute value of negative 3 is 3. That means from the center, I will be 3 up and 3 down. All right? So then we'll talk about the period. So remember, the period for sine and cosine is 2 pi. And then I'm going to take what I'm multiplying in front of the x, which is 2 pi, and I'm going to divide that. And I end up with 1, which is kind of a weird thing to end up with, but that's okay. So the distance from beginning to end is 1. So I'm going to take that 1 and put it into 4 equal parts. That can't reduce, so this is what I will add every time. All right, for my end points, I will take what's in the parentheses here, what I'm taking the cosine of, and I'm going to set that equal to 0, and then I'm also going to set that equal to 2 pi, because that's where I normally start. I normally start at 0, and I normally end at 2 pi, but I'm shifting this. So I'm just going to solve for x, so I subtract the 4 pi. So 2 pi x is equal to negative 4 pi. And then I'm going to divide by 2 pi. So x is equal to negative 2 pi. All right, then I do the same thing over here. I'm going to subtract the 4 pi. Oh, I put the pi on here, but that actually cancels, right? So it should just be negative 2. My fault. All right, subtract the 4 pi over here. So you have 2 pi x is equal to negative 2 pi. Divide by 2 pi. So I get x is equal to negative 1. And if you think about it, between negative 2 and negative 1, that's just 1, right? So I'm going to start at negative 2, and I should end at negative 1. So my first point, the x value is negative 2. These are my key points, by the way, if you want to put that on there. And I should end at negative 1. And we already established that every time I'm going to add 1/4. So if I take negative 2 and I add 1/4, I get negative 7/4. If I take that and add 1/4, I end up with negative 3/2. If I take that and add 1/4, I end up with negative 5/4. And then if I add 1/4, I should end up with negative 1, which I do, right? So we are graphing cosine, which means we normally start up at 1, drop to 0, negative 1, back up to 0, and then to 1. But I'm multiplying by negative 3. Whatever number is out front in front of your cosine, that's what you need to multiply by. So 1 times negative 3 is negative 3. 0 times negative 3 is 0. Negative 1 times negative 3 is 3. 0 times negative 3 is 0. And 1 times negative 3 is negative 3. And now we're ready to draw this graph. I'm going to actually, this is going to be main on the left, right? So I'm going to draw the x-axis like this. kind of do a backwards graph. All right. Now, the common denominator for these, because we have a 4 and a 2, is a 4, right? So if I want to make this with a denominator of 4, I'm going to think of this as being negative 2 over 1, right? I'm going to multiply by 4 over 4, which gives me negative 8 fourths. This already has a 4 on bottom. If I want to make this a 4, I would multiply by 2, so that would be negative 6 fourths. This already has a 4, and then if I want to make this with a 4 on bottom, it would be multiplied by 4 top and bottom, so negative 4 over 4, right? So I'm going to be counting by fourths, correct? So like I have negative 1 fourth, negative 2 fourths, negative 3 fourths, negative 4 fourths. That's my negative 1, right? And then we have negative 5 fourths, negative 6 fourths, which is my negative 3 halves, negative 7 fourths, and negative 8 fourths, which is my negative 2. So now I have equally spaced everything. I know I'm going to go all the way down to negative 3, and I know I'm going to go all the way up to positive 3. And I just look at my y values for that. And then I just plot these points. So negative 2, negative 3, negative 7 fourths, 0, negative 3 halves, 3, negative 5 fourths, 0, and negative 1, negative 3. So this one actually flipped it upside down, right? So we go, I hope you guys' looks better than mine because this is terrible. And then I know this is going to continue to make that wave. So now we've figured out that if we multiply by a negative out front, then it's going to flip it upside down. So instead of going like this, it's going like this, right? So that's what the negative does. It just flips it. So we know the negative out front flips it. The number out front stretches it up or down, right? Or shrinks it and makes it shorter. And then multiplying on the inside will stretch it out long ways, left and right. And adding and subtracting number on the inside shifts it left and right. Here we go. Here's our vertical translations. So if I add or subtract the number to the whole equation, now this could also be like this. You can do it outside. As long as it's not in the parentheses, that moves it up and down, okay? So if this is a positive, like a positive 5, it would move up 5. And if it was a negative 5, it would move down 5. All right? So if we're looking at this equation, I already know I'm going to be moving up 2 because this is positive, right? That's being added. I know that I'm going to stretch up and down. So instead of going up to 1, I'm going to be going up to 3, but then I'm also moving it up. And then I'm also going to be stretching or shrinking horizontally, okay? So let's start with our amplitude. So remember, the amplitude tells you how far it is from your like baseline, your center. So I've got a 3 that I'm multiplying times cosine. So I take the absolute value of that 3, and that gives me 3. Now we need to figure out how far it is from beginning to end. So for my period, I take the 2 pi and I divide it by whatever I'm multiplying the x by, which in this case is 2. So I know from beginning to end is a length of pi. So if I take that pi and I separate it into 4 equal sections, that would just be pi over 4. So every time, this is what I will be adding. All right, so for my end points, I'm going to take whatever I'm taking the cosine of, which in this case is 2x, And I'm going to set that equal to 0. And I'm going to set it equal to 2 pi. So I divide by 2. So x equals 0. That's where I will be starting. And then I'm going to divide by 2. And x equals pi is where I'll be ending, which makes sense, right? From 0 to pi is a distance of pi. And notice that I didn't add or subtract anything like in here. So that didn't move me left or right, correct? So I'm starting at the 0 because I didn't add or subtract a number in here. Okay? So now we need to talk about our key points. I already know that my first one is going to start at 0. And the last one will end at pi. Since we are doing cosine, I know that we normally start at 1, and then we drop to 0, down to -1, back up to 0, and back up to 1. So I need to figure out, first off, what all of these are, correct? So every time I'm going to add pi over 4. So 0 plus pi over 4 is pi over 4, plus another pi over 4 would be pi over 2, plus another pi over 4 would be 3 pi over 4. And then another pi over 4 would be pi. Now, here's where we have just a little bit of a difference. So we always multiply by this number, right? And now, if this is a positive 2, you add it. If it's a negative 2, you subtract it. So I'm going to take that number, the 1, I'm going to multiply it by 3, and I'm going to add the 2. So 3 times 1 is 3, plus 2 is 5. Then I do the same thing here. 0 times the 3 plus 2. So 0 times 3 is 0, plus 2 is 2. Then I do the same thing here. Negative 1 times 3 is negative 3, plus 2 is negative 1, right? All right, then we have 0 times the 3 is 0, plus 2 is 2. And then 1 times the 3 is 3, plus 2 is 5. So you always do the multiplying first, and then you add or subtract that number that's being added and subtracted on the outside. All right, so now we are ready. I'm starting at 0, so put this over here. So I know the highest I'm going to go up is 5. And then the lowest I'm going to go is negative 1. And then I know I'm going to be counting by pi over 4s, right? So this would be 1 pi over 4, 2 pi over 4, which is my pi over 2, 3 pi over 4, and 4 pi over 4, which is my pi. And then I plot these points. So 0, 5, pi over 4, 2, pi over 2, negative 1, 3 pi over 4, 2, and then pi 5. And then I draw this in. So I just want to point out, where you have these two, that's like your center, right? Correct? These two dots right here. This would represent like your baseline, correct? It has been moved up 2, right? Normally it's at 0, but now it's at 2. And from that baseline to the top and the baseline to the bottom should be 3 because that's your amplitude. So if I'm at 2, 3, 4, 5, that's a distance of 3, right? 3, 4, 5, that's a distance of 3. So I have moved my whole thing up 2. And I think that's about it.